Inside every modern AI system, a quiet revolution hums steadily, meticulously built from sophisticated mathematics, elegant attention mechanisms, and computational light. The transformer architecture fundamentally revolutionized our understanding of machine intelligence and natural language processing, becoming the cornerstone of modern AI development and breakthrough applications. Before transformers emerged, language models processed text sequentially, reading one word at a time, much like a fragile chain that inevitably snapped under the weight of increasingly long sentences. In 2017, a landmark paper arrived. Attention is all you need fundamentally rewrote the rules of artificial intelligence and transformed deep learning forever. At its core, the transformer architecture has two complementary halves: an encoder that reads and deeply understands input data, and a decoder that generates and produces coherent output responses. A sentence enters the encoder, where it is compressed into concentrated meaning, and then the decoder carefully unpacks it into a completely new language while preserving its essential intent. Words become vectors enriched with positional signals, giving the model a sophisticated sense of order and sequence within the input, enabling it to understand complex relationships and dependencies between tokens. Self-attention lets every word look at every other word simultaneously, dynamically finding and weighing which connections matter most for understanding broader context and deeper meaning. Each word creates a query, a key, and a value representation. Dot products measure relevance between them, and softmax converts scores into normalized weights. The attention formula scales dot products by the square root of the key dimension, applies the softmax function to normalize scores, then weights the values accordingly to produce the final output representation. 8 attention heads run in parallel, each one independently capturing a unique pattern of relationships and dependencies across the entire input sequence simultaneously, enabling diverse perspectives. Each of the 8 attention heads learns a distinctly different pattern from the input data. Subsequently, all 8 heads combine their individual insights into one richer, unified representation for substantially better understanding. After attention, data passes through a feed-forward network with multiple layers. Then, layer normalization carefully stabilizes the signal before proceeding to the next processing step. This entire block repeats 6 times throughout the iterative process, with each successive layer systematically building a progressively deeper and more comprehensive understanding of the original input material. The decoder uses masked attention to prevent it from seeing future tokens during processing, and employs cross-attention mechanisms to effectively draw upon and integrate the encoder outputs. From GPT to Gemini, from DALL-E to AlphaFold, the transformer architecture serves as the foundational engine powering these revolutionary systems. Attention truly is all you need.